Alright, so we've learned about chemical equations and chemical reactions and how to write a chemical equation and how to make sure that it's balanced. Now we are going to move into the different types of chemical reactions, because as you learn, there's physical and chemical, but then there are also ways to classify those chemical reactions further into different types of chemical reactions. So first, let's remember some of our key vocabulary and review that so that we have a strong base when we're ready to learn about the different types of reactions. So first, we're going to talk about our background knowledge. The parts of a chemical reaction. If you remember, there's a name for what is the chemicals at the beginning, and then there's a name for the chemicals at the end. So at the beginning of the reaction, we call these our reactants. These are the chemicals that are going to be used in the reactants. And what we get at the end are our products. The end of the reaction, that is what we had. If you're baking a cake, your reactants would be your flour and your sugar and your butter and your eggs, and your product would be your made cake. So another important part of our chemical reactions is actually the elements and compounds that go into our reaction. So if you remember, an element is made up of, when we're writing our symbols, is made up of only one capital letter. Right, so some examples of this would be Fe, which is iron. H2 is an element. O2, Mg. Those are all single elements because there's only one capital letter in each of them. However, a compound is two or more capital letters. So some common examples we've seen is H2O, CO2, FeNO3, 2. Those are some examples of our compounds that we're using in chemistry. Okay, I'm going to switch colors because I'm kind of going to color code things here. I like using color coding because it makes things easier to keep in track in my brain. So for synthesis, use this kind of blue-purple color. So when we're talking about a synthesis reaction, it's two or more elements or less complex compounds come together to form a single, more complex compound. So you have two things becoming one more complex thing. Let's start with the example and then let's work our way up. So a very common example, and something so we're forming a compound that you know is water. How do we form water? Well, we have H2 plus O2, and that's going to give us H2O. Now I'm going to take a minute. I want you to pause this video and I want you to balance this equation, because you know how to do it. I left space so you can balance it. When it is all balanced, it should look like this. You have two H2s plus one O2, giving you two H2Os. All right, so let's make a common description that we can use for all synthesis reactions. We're going to say it's an element plus an element, giving us a compound. And just like in math, when you use X or Y to substitute for a number, we're going to do the same thing, but here we're substituting for elements. So we're going to use A plus X is going to give me AX. It should be a capital X because they're two different elements. We're making a compound. So that is what a synthesis reaction is going to look like. Now now we're going to move down to our decomposition, and I'm going to switch colors. I'm going to switch to kind of this pinky red. So for a decomposition reaction, you've probably heard of the word decomposition before. Anyone know it? Decomposition means to like break something apart, to break it down. That's exactly what we're doing. A single compound breaks into two or more elements or less complex compounds. So we're breaking it down. All right, again, we're going to start with our example and then build up from there. So the example we're going to use is mercury. We use HGO plus, oh, nope, we're going to go right into an arrow. There is no pluses here. We go from a compound right into our arrow. You get, I meant to have you balance this, but I accidentally already did it. Okay, so we have two HGs over here, balance the rest of it. That would give us two HGs, O's over here, and we have an O2. So that's our decomposition reaction. We have mercury oxide breaking apart into mercury and oxygen. All right, so we're gonna give us a description. What does this look like? We got a compound over here. And this is gonna form an element plus an element. How do we write this as a general equation or a format equation? It's the opposite of our synthesis reaction. So AX, arrow, is forming A. Oh, this should be a capital X. AX is forming A plus X. And that is our decomposition reaction. Anytime you see one thing on the left side of the arrow, immediately your brain can go, decomposition. All right. So now we're going to move into our last three. Switch colors to talk about single replacement reactions. So, a single replacement reaction is when an element replaces another element in a compound. Okay? So it's kind of a substitution, is another way I think about it. So, single element replaces another one in a compound. So, for example, we're going to use zinc and hydrochloric acid. I'm not going to balance the equation. You're going to do that. It's going to give me 2 CnCl2. Okay. Now take a minute to balance your equation. All right, to get this all balanced out, we're just going to place a 2 in front of our HCl. Is that what you had? All right. So our description, all right, zinc is an element plus our compound of HCl. Going to form another element substituted for H2 plus a different compound. That's all it is. We're just swapping one element for another in that compound. All right, so our format of our equation, we can write this two ways. We've got A as our element plus BX is our compound. And that is going to give us, or we're swapping. So the B is going to be all by itself plus the AX. So typically when we're using A, B, C, X, Y, Z, our A's, B's, C's. The beginning of the alphabet is going to stand for a metal. The end of the alphabet is going to stand for a non-metal. Not really something you have to worry about, just a little tidbit of information, as if you're asking, like, why am I using A or B versus X or Y? That's why. So the other way we can write this is it doesn't have to be metals doing the replacing. Here we're going to use Y to signify a non-metal plus BX, and that's going to give me X plus BY. Remember, when you're writing a formula, your non-metal, or your metal always has to go first. That's why we still have BX, even though we're swapping out for the X or the Y. All right, so it's single emplacement reaction. So now I'm going to swap to a different color to talk about double replacement reactions. In a double replacement reaction, ions in a compound switch places with ions in another compound. So you have two compounds, they're going to flip-flop to become two different compounds. All right? These, I think, are the hardest. So here we got Ki plus Pb NO3 2. That's going to give me KNO3 plus PBI 2. All right, you balance this. Pause it if you need to, because I'm going to give you the answer. 2Ki and 2KNO3. That's how we have that balanced. All right, so what's our general description? We got a compound. This is a long one, so I'm going to write smaller. Plus another compound. That's going to give me a compound plus another compound. So, if you see two compounds in the beginning, it is either going to be the double replacement or the combustion. We're going to talk about what makes combustion special. So normally if you see two compounds as reactants, it's going to be a double replacement. That's an easy way to remember that. All right, so what's our general format equation? AX plus BY is going to give me AY plus BX. So we swap partners. We're swapping dancing partners in a double replacement reaction. All right, let's talk about our last one, and I'm going to use red because for me, combustion reminds me of red. So combustion is a hydrocarbon compound reacts with oxygen to form carbon dioxide, water, and heat. So this is one that you're probably very familiar with. Anytime something gets lit on fire, anytime something burns, this is a combustion reaction. These are the hardest to balance, but to me personally, I think they're the easiest to spot. So let's talk about an example. So we're going to use CH4, which is methane, plus O2. That's going to give me CO2 plus H2O. So we're always going to have a carbon and oxygen giving you CO2 and H2O. And you got heat over here, which makes it endothermic or exothermic? Exothermic. If it's giving off heat, heat is a product of this reaction. Okay, I want you to balance this. These are kind of tricky because you have oxygen and oxygen, so you have to add those together to make sure it's balanced. Pause it here if you have not finished, because you've got 2 O2s and 2 H2Os, and you have it balanced. All right, so our description is, this is the most descriptive description. It's the most detailed. So you start with a hydrocarbon. That's just like what it sounds like. Hydrocarbon compound. You got hydrogen and carbon. That's all it is. Plus oxygen is going to give me carbon dioxide. Plus water. Cool fun fact is combustion reactions happen in your body all the time. When you eat sugar, pretty much anytime you eat, you're eating a carbon-based compound. That's why you need to breathe in CO2 to form a combustion reaction, and then you breathe in O2, and then you have a combustion reaction occurring in your body, so you're breathing out CO2 and water. It's pretty cool. Combustion reactions happen all the time within your body. So how do we format this? Again, this is very detailed because it always follows the same exact format. The only thing that changes is the hydrocarbon. CX, X meaning that this can be any number, any whole number. HX, again, these can be any whole number. Plus O2 is going to give me CO2 plus H2O. So the only things that are going to change in a combustion reaction are these X's and the coefficients to balance the equations. It's the only thing that's ever going to change. Okay? So your job with this is to be able to identify. If I give you an example, like say I give you KiPbNO3, 2, and I give you this equation, your job is to be able to identify it as one of those 5 terms. I'm never going to give you one and just tell me to identify it. I'll always give you a word bank. But that is what the goal is of this. Okay? Tomorrow we will be doing a practice about how to identify those, so watch the next video to see that.